These are the terms and definitions for this module. First of all, CIW represents the command interpreter window. When we talk about the skill evaluator, we're talking about the evaluator that runs the skill programs in the Virtuoso design environment. And when you load code into the environment, the program source code is compiled before running the program. So you load it, it loads it into the environment and prepares it for you to run it at a later time. Next is evaluation, and this is the process where the skill evaluator determines the value of a skill expression. Maybe it's evaluating like an arithmetic expression like 5 plus 7, for example, or maybe it's evaluating a function definition, in which case the name of the function is returned and it's ready for invocation. Now, a skill expression is what we consider the basic unit of source code. It can be an invocation of a function, and often by means of an operator supplying the required parameters for that function. A skill function itself is a named parameterizable body of one or more skill expressions. And then you can run any skill function from the CIW by using its name and providing the appropriate parameters. And in skill and in this class, we will refer to both a procedure and a function interchangeably. So we don't differentiate between the two in this class. What is the skill language? The skill programming language is a high-level interactive language. It was developed and is based on Lisp, which is a list processing language. So what you'll see is a lot of input to commands and output from commands are in fact lists of data. The I/O used in the skill language resembles that of C. You can use the C syntax to create your code, or you can use the Lisp syntax. You have the option of using either. It is also the command language of the Virtuoso design environment, meaning this language allows you to customize and enhance that design environment to your needs. Also, whenever you use forms, menus, buying keys within the environment, the software actually calls skill functions to complete your task. So for example, when you invoke the create rectangle option in the layout environment, it in fact calls a skill function to create that rectangle. You can also enter skill functions directly into the CIW input pane and bypass the normal user interface. So this allows you to quickly write a small procedure, to quickly invoke a function without using the user interface. In the window at the right is an example of the command interpreter window. The lower part is the input pane where you would, for example, define a procedure like TR display message, which basically takes an input and then prints out a message with the word important in front of it. And then you can invoke that function, TR display message, and see the output in the pane above where it actually says important, use skill now as the output of that particular command. So what can skill functions do? The skill language acts as an extension to the Virtuoso design environment. Some skill functions control the Virtuoso design environment or perform tasks in design tools. For example, skill functions can open a design window, such as a schematic or a layout. You can use a skill function to zoom in by 2 or to zoom to a particular location in the design. You can use skill functions to create data, such as placing an instance or a rectangle in a design. Other skill functions compute or retrieve data from the Virtuoso design environment or from specific designs you're working on. For example, skill functions can retrieve the bounding box of the current window. That's the location on your screen. Or if you're looking at the data in that window, they can retrieve a list of all the shapes, for example, on a given layer purpose pair. When a skill function executes, it will return a value. And for example, in the first case we'll look at here, you can assign the return value to a skill variable. Okay, so in this particular case, we're going to store the data selected in the current design window into a variable. So the function GEGET_SEL_set will capture the data that you've selected in the design window and then store it in the variable called mySelectedData. Okay, so the return value of GEGET_SEL_set is a list of items selected in the window by the user and then stored in mySelectedData. In the second example here, we will pass the return value to another skill function. So in this particular case, we'll be using the same function that we used in the prior example, GEGET_SEL_set, to collect the data that the user selected into a list. The return value of GEGET_SEL_set is then passed into a function called trPrintInfo. Now in this case, trPrintInfo is a function we've created. It's not a built-in skill function. So we've created our own function to print out information about the data that was selected. So that in this way we have our own custom print utility to look at particular types of data. Now another thing to note is that any skill data can become a return value. So when you write your own functions, you can return lists, you can return symbols, you can return values, whatever fits your program's return value information can be returned to that. Okay, so now that we know a little bit about what skill is, what skill functions can do, and types of data that can be returned by skill functions, let's step back a little and look at how do we use skill in the Virtuoso design environment. So we have two types of sessions that we can work with. One is a graphic session. The other is a non-graphic session. So you can replay a Virtuoso design environment session also. So if you've created one prior and captured the log file, you can use that log file to replay the design environment session. So first of all, for a graphic session, you would enter in the Unix command line virtuoso space ampersand. Okay. Now the ampersand actually places the application in the background. Okay, you don't have to use that, but if you want to continue to use that Unix window, you would need to place it in the background. Virtuoso also is the name of the executable. In prior versions, in the IC51 environment and early 6.1, we allowed you to use multiple names like ICFB, Layout, Layout Plus. These were segmented executables. They were subsets, but in 6.1.4 going forward, we're requiring only one command to be used. If you used any of those other ones, there's no longer a wrapper to execute Virtuoso. You will get an error. So the net effect of this is if you have scripts that call the other executables like ICFB, Layout, Layout Plus, ICMS, you're going to need to go in and modify those wrapper scripts to call just Virtuoso. The other option we have here is non-graphic. So in this particular case, Virtuoso dash space dash no graph would allow you to start a non-graphic session. And what this will allow you to do is it will just in the Unix window show you some of the initialization messages from the Virtuoso design environment, and then you'll get a prompt. And at that point, you can just type in the Unix window skill commands that will work on your data or that will look up information, so you can then work in a non-graphic mode. The last example here shows you how to replay a session. So in this case, Virtuoso space dash replay space log file name space ampersand. Okay, so what this again does is if you have a log file from a prior session, you can replay it. And what we'll do is execute all of the commands that you did in the prior session. It will pop up windows, it will enter data, it will move windows and data just the way you had done it in the prior session. And then when it gets to the end of the log file, it will stop and you will see where you were in that last session. Okay. Two reasons to use the replay. One would be if you were going to set up, say, a demonstration and wanted to save the time it takes you to set it up by just recording it in a log file and replaying it. The second option would be is if you're working with customer support and trying to explain to them the steps you took to get to a certain point where you have an issue, maybe a warning, a bug, something that you want to have them duplicate. Now you could try to tell them all of the steps you took, and they may or may not be able to reproduce that problem. So by sending them, say, your log file, they could then replay that session. Now one caveat here is that they would need, for example, libraries of data that you had opened in order to run that particular log file. When you initialize the Virtuoso design environment, you'll be doing it with a file called .cds init. There's a standard sequence of locations that the software looks for the .cds init file. The first is it will look in tools df2 local. That is the system directory that typically the system administrator would manage. Next, if it does not find it there, we'll look in your current directory or dot, and finally it will look in your home directory. Now when the Virtuoso design environment finds a .cds init file, it stops searching and loads the .cds init file from that location. Now things you would typically do in a .cds init file would be to define application bind keys, load some customer specific skill utilities you've created for use in your environment. At the right here we have a short sample of a .cds init file that's used in the class. You can see there's some custom load functions we've created to load, say, bind keys. We've wrapped those in a when statement, for example, that says when is file lebindkeys.il, then load it. This prevents warning messages in case for some reason that particular file is not present. You can see comments of different functions that we're either including or excluding. So when we don't want a function to execute, we might put a comment in front of it temporarily. You can also see in the last line here, we're setting some variables. One of them here is the editor variable, which determines what editor pops up when we enter the edit command in the command interpreter window. So in this particular case, we're popping up the VI editor. You can set the editor to edit any editor you would like. VI is a good one if you're familiar with VI. A more powerful VI one is called GVIM, and you may want to look that up. That's actually from the an open source type application from vim.org. Here we'll look at the command interpreter window. You'll be using the command interpreter window to enter skill commands and see the output of those skill commands. Starting at the top here, you can see the title of this particular window is the name of the executable, Virtuoso 615, and then a path to the log file where the output is being logged. Next, you'll see the menu banner, which has various menus that have commands and other utilities under them. The next thing you see here to the right is that the middle bar here between the output and the input pane can actually be resized. So what you can do is grab that with the mouse, the left mouse click, and then move it up or down to make the input or output pane smaller or larger. One benefit of this over the prior version of the software is that the input pane can now be more than a single line, which gives you a very easy place to develop and test your skill code, because you can see multiple lines at one time. You can actually edit a line that's in the input pane, hit enter again, it will re-execute that line. You can copy and paste, so it's a very convenient place to actually develop and test your skill commands. The other thing to note in the input pane is the syntax is color coded, meaning for example, in this case the functions are in a dark blue, the strings are in green. So as you type and you complete a string, for example, it will keep everything between the double quotes in the color green. Something that's not shown here, but in the output pane, for example, there's also color coding with regards to warning and error messages. Warning messages would be in a yellow or gold color, and the error messages would be in a red color. A new feature in 6.1, one of the later releases of 6.1, is this license usage indicator, which shows basically when a license is being accessed by the system. There's more information on this in the manual if you're interested. At the bottom we also have mouse button cues. So depending on the command you're in, the function of the mouse buttons can change. So, and you'll see the command that you can execute by clicking on any of the buttons at that point in time. At the bottom of the window here we see we have a prompt pane. Now that prompt pane will, depending on the command, have a prompt for you. So let's say you're zooming into a particular location, you activate the zoom function. It would then, for example, prompt you to say enter the first point and then enter the second point of the area you want to zoom into. So looking at this prompt pane can assist you in knowing what the command is expecting you to do next. The lower left corner shows a window number. For the command interpreter window, this is always window number 1. For other types of windows, there will be a number there showing you the number of the window. And in 6.1 we have session windows, so there are actually 2 numbers. There is the session window number, and then in parentheses there is the actual window number. Now at the bottom here you'll see there's an input pane, and that input pane again is where you're going to be entering commands. We mentioned earlier it had color-coded syntax. You can either type commands in this window or this pane, and then you can also cut and paste commands, say from a text editor, into this window. Another function we'll discuss later is the load function. So if you have a skill file in the Linux environment that you want to load, you would simply say load and then in double quotes put the file name. So this is the area where you'll be entering data, loading files, and cutting and pasting skill code. And then finally, above that we have the output pane. And this is where you'll see the results of the commands that you enter. For example, with a printf statement, one of the results is the actual string that's printed out. As we note here, multiple lines of input are allowed and can be edited here. The editing would occur in the input pane, of course. But the string is output, and then you'll see after the multiple lines of input there's a T. And printf returns T when after it prints the string. The return value of the printf function is simply T. Or in skill, the T indicates a true condition. Here we'll look at customizing the CIW using the user preferences form and the CIW controls section of that form. You can see we would select it from the options menu, select user preferences, and then scroll to the part of the form here that identifies the CIW controls. Here you can define the input area section as far as the number of lines. You can, if you want, click on retain unique commands. So if you're re-entering commands multiple times, say you're testing code, by default it's going to have every time you entered it logged in the history. However, if you click on the retain unique commands, if you entered a command 10 times, it would only show up once. This makes it easier to scroll back and locate prior commands. Another nice feature is history in place. That allows you to use the up arrow to go back to a prior command without having to use the mouse to scroll. And then in the bottom right corner of the CIW controls section, you have the option to raise the CIW on warning or error. This is handy if you're working in the design environment and an error is generated or a warning that will automatically bring the CIW window to the top on top of your design window so you can quickly see what the error message is. Without this feature, sometimes you'll be getting an error, but it won't be easily identifiable to you until you do go locate your CIW to find it. So this will save you a few clicks if you're running into errors or warnings that you want to be aware of. Here we want to look at the color-coded syntax feature of the command interpreter window. So skill language keywords are highlighted in blue by default and the strings are in green. We'll see that in the examples below. In the first one, what you'll note in 616, this is new, as you're typing, you'll see the background of the command highlighted in a light yellow color. This indicates the command is not yet complete. Once you do complete the line, as we see in the next bullet, you'll see the matching parentheses highlighted left and right, and the background changes from yellow to white. Now if you are typing along and you do insert an extra parenthesis in the line, in this next example you can see that skill automatically highlights that in red, indicating to you that that is an extra parenthesis. And in the last example here, you can see we've entered several lines into the CIW, and once the final parenthesis is entered, we can see the block of code highlighted from parenthesis to parenthesis in a light gray background. Not easily visible here, but you will see it on your system. This is a demo of using the command interpreter window for skill programming related tasks. The Virtuoso Design Environment User Interface involves a wait, evaluate, and display loop. We see here on the left there's many ways to provide input to the environment. First is a buying key, then a menu item, then a form callback. You could load a file. You can enter data into the CIW input pane. You can replay a log file, and you can also communicate with a Linux process, which would send a skill command to the evaluator. Once the command is sent, the loop which had been waiting will now read that skill expression. It will then evaluate it and display the return value, and then wait for the next command. Now the return value itself will be sent to the log file, and then depending on a filter that you can set, some or all of the data would be displayed in the output pane for the user. Here we'll look at setting the log filter to allow us to filter the data that we want to see in the output pane. So by default, all of the information is stored in the log file, and only particular data that we want to select will then be displayed in the output pane. Now there's two ways to do this. One is to use a function, a skill function, and you can place it in your .cds_init file. The function name is called HISetFilterOptions. And then for each parameter you specify, it will either turn on or turn off a particular output item. So you can see here in the table the order of the parameters and what each parameter will either turn on or turn off. Now to turn on an item we use T, and to turn off an item we would use nil. T means true in skill and nil means false. So here we have 7 inputs. Each of them will then control what we see in the output pane. Now alternatively, we have a user interface option to do this. In the command interpreter window, we can select Options, Log Filter, and we'll see a form pop up called Set Log File Display Filter. And there we can click on or off the particular items we want to see or not see in our output pane. Here we'll examine the cds.log file. The session that you are using will be transcribed into what is called the cds.log file. Within the file itself, what you'll see for each line is a 2-character prefix tag that identifies what type of line it is. And in this example here, we have several different types of lines highlighted. The first one here is a prompt, which begins with a /p. The next line here is an input line that the user typed in. It begins with a /i. The return value is prefixed with a /t. Then we have another prompt, then another command that the user typed in with a /i. The /o is the output of the skill command. /t is a return value again, another prompt, and then the /a is indicating an expression that was activated by, say, a bind key or a menu, but again an input, and so on. So we see various types of inputs and outputs. The two inputs are the /i and the /a. So if you were going to replay this file or look at it from what commands were executed, you would look for those with a /i or a /a prefix. Next, we'll examine valid skill syntax. You see here we have a table with the syntax category, the type of item that syntax represents in skill, and then an example of the syntax. So first of all, we have comments, which can be either single line or multiple lines. The examples here are a semicolon, and then the remainder of the line is considered a comment. Or for multiple lines, we can bracket them in a slash star star slash syntax, and that indicates that everything between those two slash star and star slash symbols is in fact a comment. For data, we have several types. First is an integer, represented in this case by a number 5, a floating point number, represented by 5.3, a text string, which is the string "this is text" enclosed in double quotes, a list, which is a list of different types of data, it can be same or different types, enclosed in a set of parentheses. For Boolean data, we have T, which indicates true. The semicolons here are a comment. One or more indicates a comment. And nil, which indicates false. We have variables. There is the basic name of the variable. For example, line underscore count1. There is assignment to a variable. So here we are assigning 5 to the variable named x. And if we want to retrieve or look up the value of something stored in a variable, we would use just the variable name itself, x. If, for example, no value had been assigned to x, skill will return a symbol called unbound. Next, we have function calls. There's two formats to these. One is the C syntax format, which you can see here is strcat parenthesis, then the two strings that are being concatenated, good and day, followed by a closing parenthesis. So the parenthesis in the C syntax immediately follows the function name, which in this case is strcat. No spaces are allowed between the T in strcat and the left parenthesis. Next, we have the Lisp syntax, and that basically is the same as the C, except the parentheses are on the outside. So the parenthesis occurs first, then the function name, then the input arguments, followed by the closing parenthesis. So skill allows either of these syntaxes within your program. You can intermix them if you want. Typically, you will see programs written either entirely in C or entirely in Lisp. And finally, we have the operators. Typical operators, and we'll look at these in more details on further slides, would be the plus and multiplication. So we have 4 plus 5 times 6. We also have the equivalent functions for those, which in this case is plus and times. You'll see that there is a precedence, so times occurs first, 5 and 6 are multiplied, those then become inputs to the plus function. Skill has various types of data. The reason that understanding data types is important is, first of all, that you need to specify the correct type of data when passing an argument to a function or assigning it to a variable. The second reason is the skill evaluator will use the print representation as a default format when displaying the data, unless you specify another format. So when printing, the type of data becomes important. Later on, we'll see various ways to print data and specify a format for it. Now, what the skill documentation does is designate the expected type of data with a single or double character prefix preceding the variable name. If a variable can be one or more types or an unrestricted type, the letter G is used in that case. The following table summarizes several common data types. The first here is integer, which has an input syntax example of the number 5 and a print representation of the number 5. The type character used in skill to designate an integer is an X. And for example, if you were going to see this in a syntax description for a parameter, it would say X underscore count. Next, we have floating point. Here, for example, the input syntax is 5.3. The output syntax is also 5.3. The character type is F, and the example here is F underscore width. So if the input parameter to a function required a width, then you would need to specify it in floating point format. Next, we have a text string. Text strings are enclosed in double quotes, as the input and print representation show. The type character is T, and an example here is T underscore MSG, meaning if you were to supply a message to a particular function and it had a T as the character type, you would need to specify a text string. And in the last example here, we have list. The input syntax for creating a list is single quote, in this case, single quote parenthesis 1, the string 2, and then the number 3, 4. The print representation is the list with a set of parentheses around it. The type character for a list is L, and so for example, if you saw this in a syntax description and a function needed a list of items, it would be L underscore items. Here we'll look at the syntax needed to declare a variable in skill. The skill evaluator will create the variable the first time we use it, so we don't need any special declaration to declare it like some languages have. We just simply use it, and the first time we use it, skill will create it. Variable names can contain alphanumeric characters, underscores, and question marks, with the restriction being the first character of a variable cannot be a digit or a question mark. And also, it's important to note in skill that the variable names are case sensitive. When we want to store a value in a variable, we use the assignment operator, which is the equal sign. And then if we want to retrieve the value of a particular variable, we simply enter the variable name and it will return to us the value. Here we're going to do some assignments and retrievals and then use the type function to check the type of data that is stored in the variable. First of all, we have line count equals 4, and you can see 4 is assigned the value. We then enter line count to see the value returned, and if we execute the type function passing in line count, we see it is in fact a fixed number. Next, in the same piece of code, we assign line count to the string ABC using the same variable name. This is legal in skill. You can see then by entering line count, we retrieve back the string ABC, and now executing the type function again, passing in line count, we see now it is a string. So a quick summary here is that skill is not a strongly typed language, but is in fact flexible in allowing you to specify different types of data to the same variable. So this has both pluses and minuses obviously in the code. It allows flexibility, but then requires more discipline on the programmer to check the type of data. What is a skill operator? The skill language provides operators that simplify writing expressions. They can be used in place of the equivalent functions. First, we'll compare two equivalent skill expressions. On the top, you have the typical way of writing an expression with operators. You have 3 squared plus 4 squared in parentheses with the result raised to the 0.5 power. Below, you can see the equivalent expression with nested operator functions, which produces the same result. Next, you can use a single pair of parentheses to control the order of evaluation, as this non-graphic session transcript shows. Note that assignment has the lowest priority and would be evaluated last, but even that can be overridden with parentheses. Note, however, that using extra parentheses can cause an evaluation error. Skill will interpret the extra set of parentheses in Lisp mode and assume that what is inside the parentheses is a function. Here we will look at operator precedence. In general, evaluation proceeds from left to right. The operators are ranked according to their relative precedence. That precedence is shown in the table at the left, where the operators higher in the table have a higher precedence than those lower in the table. Each operator listed in the first column corresponds to the operator function in the second column. And if you want more information, you can always look it up in the online documentation. For example, you could search for information on the operator function pre-increment. You can trace operator evaluation using the built-in function traceF. This is useful to see how an expression is being evaluated. So to invoke the traceF function, you would enter into the CIW traceF paren, the operator function names paren. In the example, the operator functions are the plus and times functions. So once you have invoked traceF, now later when you execute a skill expression or program, it will then show you all the steps in evaluating the parts of the expression that involve those functions. So in this case, we have in parentheses 3 plus 4, and that result is multiplied by 5. Looking at the trace information next to the vertical bar, you can see 3 plus 4 is input to the plus function, which returns 7. 7 is then input into the times function. So 7 times 5, and you can see the result of the times function is 35. So this is useful if you're working with small programs and expressions where you want to see how the evaluation is proceeding within the skill evaluator. Now, once you have completed doing your analysis with traceF, it is useful to turn tracing off. You will use the function untrace to turn it off. If you don't turn off tracing and you continue to run programs, you will get a lot of additional information regarding tracing output in the command interpreter window that you may not need. Now note that traceF with nil as an input is not the correct syntax. Use the untrace function instead. You can also pass t into the traceF function to trace all functions, but this will likely produce more information than you want.
Next, we'll look at function calls in skill. The first thing to note is that function names are case sensitive, so you need to be aware of that as you're entering, especially built-in commands. The typical syntax is that if there's multiple words combined together, like HI create rectangle, for example, the C on create and the R on rectangle would be capitalized. Okay, that's the general rule. There are exceptions, but again, be aware of the fact that function names are case sensitive. So skill syntax accepts function calls in 3 ways. The first that we'll look at here is what we typically call the C syntax. So we state the function name first, followed by the arguments in a pair of matching parentheses. No spaces are allowed between the function name and the first left parenthesis. So here, for example, we use the strcat function,
which is a built-in function to concatenate strings, and we see a series of input parameters that are strings passed into it. In the second case here, this is typically what we call the Lisp syntax. We place the left parentheses to the left of the function name. Then we specify the function name followed by the parameters. Again, the result is the same, but we have above the C syntax, and in this case the Lisp syntax, where the parenthesis is specified first. And finally, we have an option here where you don't need to specify any parentheses, in this case the outer level, for the strcat command. The primary use for this would be in the command interpreter window. If you're testing some code, want to see how a function works, you can exclude the parentheses. This would typically not be recommended in a program, because in a program parentheses are important to both track and manage the flow of control in the program. And the other thing to note here is white space separates the function arguments. Some languages accept commas. Skill expects white space. Now you can also combine these together. You can mix the C, the Lisp. I would not recommend just using the function without any parentheses in a program, other than possibly to test it in the command interpreter window. So a skill program or function call can span multiple lines. The limitation here is that a literal text string cannot span multiple lines. So here's some examples of function calls. In the first one here, we are spanning multiple lines in either the CIW or source code file with the strcat command. We are specifying multiple lines of input parameters and then completing the command with the closing parenthesis. So as you enter this in the CIW, for example, you would enter strcat, then a skill program on the next line, and then automates tasks on the following line, and when you finally hit the closing parenthesis, it would then execute the strcat command. Now the second option here, we show several function calls on a single line. We use spaces to separate them. So in this case, we have gd equals strcat with the input parameters good day, followed by the command printline gd. Now the skill evaluator will implicitly combine several lines into a single skill expression, and then the composite skill expression returns the value of the last skill expression executed. So in this case, in the one above, printline would be the value returned, and any other return values would be ignored. Function arguments. When you're working with skill, you want to study the online documentation or the Cadence Skill API Finder to determine the specifics about the arguments that are needed to be passed to skill functions. The documentations for each argument tells you, first of all, the expected data type of the argument. That's the prefix, so whether it's a text string, an integer, or a floating point, and then whether or not that argument is a required parameter, optional, or keyword. Now a single skill function can have all three kinds of arguments, but the majority of the functions have the following types. Typically they're required arguments with no optional arguments, or they're keyword arguments with no required and no optional. But again, they can be intermixed. Typically though, you'll see either required or keyword. And then the skill evaluator will display an error message when you pass arguments incorrectly to a function. So if you pass in the wrong type of data or the wrong number of arguments, you will get an error message. And if you would like to see the list of all arguments for a given function, you can use the built-in function called arglist. So you would specify arglist and pass in the function with a single quote in front of it. And the single quote in this case indicates do not evaluate the name, just pass in the name of the function without trying to evaluate it. And so in this case, for the printf function, you see returned t underscore string, which is the format string for the printf, followed by optional g general. So with printf, you have a format string, and then you have one or more arguments of any type that you can pass into the printf function to print the values for those variables. Here are some function argument examples. The first one would be required arguments. You must provide each required argument in the prescribed order when you call the function. So an example of this would be the HI set filter options function we saw previously, where we needed to supply 7 arguments to HI set filter options, and then each one would either turn on or off a particular item in the output pane. The second one here is optional arguments, and what this means is you don't have to provide them. Each one that you don't provide would in fact have a default value. Now, one of the keys here, if you provide an optional argument, you must provide all of the preceding optional arguments in the correct order. So this can be a little tricky. You usually have to look at the documentation to make sure you get the correct number and then know what to specify for a default value. So the example command here is the view command. The one required argument is the file, because what view will do is take the file that you specify and pop it up in a window for the user to view. Now optionally, these additional arguments here have square brackets around them. You can specify a box spec, which is the size of the window, a title. So by default, you would have a title for the window that would be the file name, but you could specify a different title here. There's an auto update feature, either T or nil, that says if I'm updating this file in the file system, do I also see the update in the file window I'm viewing? And so by setting that to T, if you were continuing to write to the file in the file system, the user would continue to see the updates appear in the window they were viewing. And then the fifth argument here is the icon position. And again, that would be the location when I iconify it, where it would go. So you have a variety of options here. Again, if I wanted to specify, for example, auto update, I would need to also specify the box spec and the title prior to auto update in order to set that argument to a particular value. Now the third option here is keyword arguments. So when you provide a keyword argument, you have to preface it with the name of the formal argument. Now the nice thing about keyword arguments when you call a function is you can provide the arguments in any order. So you're not required to know the order because you have a name value pairing. So for example here in the GE open command, I can specify question mark window and then the window ID, question mark lib and then the library name, question mark cell, the cell, question mark view, the view, question mark view type, the view type, and question mark mode, the mode. Now many times keyword parameters will also have default values. So for example, in this case, if I did not specify the mode, the default would be to open it in read mode, for example. So again, keyword parameters, you don't have to be concerned about the order, only the correct pairing of the name and the value in order to invoke it. The other advantage of keyword parameters is when you read the code, it's very obvious typically what that particular argument value is being used for. When you have positional, you would have to go look at the manual or guess a little bit as to what a particular value means. But because you have the name of the keyword argument in the syntax here, it's usually very easy to read and understand what the arguments are being used for. Continuing on in the skill fundamentals section, next we'll look at some options for displaying data in the CIW. So every skill data type has a default display format, which we call the print representation. And the skill evaluator displays the return value with its print representation. And oftentimes what you'll see is skill functions will display data, maybe from other print functions or things like that, before they return a value. And what we'll be looking at is, for example, the print and print line functions, which use the print representation. We'll also be looking a little bit in a few slides at a function called printf, which allows us more control over the formatting of the output of the print statement. So as an alternative to the print and println functions, which simply use the default format of the data they are printing, we can control the format of how the output looks with a function called printf, which is short for print formatted. Here, for example, we see the syntax printf, and then in a set of parentheses, the first thing we see is the control string. And the key items here are, first of all, we see this /n, which means new line, followed by the %s, %s, %d, 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 %d. So in essence, we have 2 strings and 4 integers. Now in front of the s and the d's, which indicate strings and integers, we have a formatting control, which we'll talk about briefly. But basically, we're controlling how many spaces we're allowing in the output for that particular string. So the first string we're allowing 15 spaces, second one 15, and then for each of the integers we're allowing 10. The minus sign in front of the 15 and the 10 in these format specifications indicates we're left justifying the output. So in this particular case, for example, the first string is taking in the variable layer name. The second string is taking in the variable purpose. And then the integers are going to be printed in the order of rec count, label count, line count, and miscellaneous count. So another key point here is you need to have, for each format specification, like a S or a D in this case, we need to have one variable that maps to it in order. The other thing to note here is the formatting is basically, in this case, going to provide us with columns of data. Because let's say, for example, our layer name is only 6 characters long. For example, let's say we have a layer name called Metal 1, and it would print out all 6 characters, and then it would add 9 spaces to account for the 15 spaces allowed in the format specification. The same thing goes for purpose, etc. So what you end up with basically is nice columns of data, because, for example, purpose won't start until column 16. Now, one potential issue is, let's say you had a layer name that was longer than 15 characters. It would still print, and it would print all 16 characters. It's just then you would be messing up sort of the next column. The purpose column would be shifted over by 1 character in that particular case. But again, this would allow you to control, the justification, the number of spaces, and then the type of data that's being printed. Here in this section, what we're describing is the general syntax of the printf. So you can see, first of all, there's a %, there's an optional minus for less justification. If we're working with floating point, there's a width and a precision. If we're just working with integers or strings, there's only a width. And then the conversion code, which is listed below, is a character that identifies the type of data we're printing. And you can look at the conversion codes here. D is for integer or digit, F is for floating point, S is for like a string or a symbol, C is for a character, a single character, N is numeric, meaning it could be floating point or integer. And then L is typically for list, but it also means default format. So it kind of works like print or println, and whatever you provide for that L conversion code, it will simply use the default format. And again, this is useful. Maybe the first time you write your code, you want to put in L for everything, simply because if you happen to get sort of data that you did not expect, say for layer name, instead of getting a string like you would expect, you got nil or a number or something else. The printf would then fail at that point rather than continuing on. So a lot of times by putting the %L directive in there in place of what you would really like, you can have your code at least complete normally. Maybe some of the output is not exactly what you want, but the printf will not fail if it gets the wrong type of data if you use %L. Here are several printf examples. First of all, we'll look at the printf function basically set up with incorrect input. So what will happen then is we'll get an error message. So in this case, we say printf, and the format control string is %d%d, which means we're expecting 2 integers. So then as input, we give the number 5 and the floating point number 6.3. So this is not matching the format specification. And so we get an error message, fprintf, sprintf, format spec incompatible with data. And then it says 6.3 is the value that it's concerned about. So you can see it will flag an incorrect type of data passed to it. In the second one here, we see the %L directive, which means we use the default. And it's a convenient way to intersperse application-specific formats with default formats. So in this case, we're going to be using it to print out a list. Printf, in fact, returns t after it prints out what you specified for it. So in this case, we create a list with the single quote function. A list equals quote 1, 2, 3. To print out that list, we say printf, and that control format, we say this is a list colon %L. So where the %L is, we want to substitute in the variable a list, which is a list. And because it's going to use the default format, it will simply print it out. So we see this is a list colon 1, 2, 3. We have the new line character, we get a new line, and then we see the return value of printf itself is t. You can use sprintf to create strings in your skill programs. So a related print command, sprintf, is used to create strings to be used within the program, or you can use them to create strings to be assembled prior to printing to the CIW, for example. sprintf has the same formatting controls as printf, but assigns the result to a variable, which is the first argument to sprintf. The resulting string is also the return value of sprintf. So here we see the syntax for sprintf, where we need to supply either a variable or nil. Now if we supply nil, there's still a return value from sprintf that can be assigned to a variable. But we can also just put the variable as the first argument. Then we have the format string, which is the same as the printf command we just examined on the previous slide. And then we have the argument list of the different variables and values that we want to print. So here's some examples. In the first one, we're going to supply a variable as the first argument. That variable is called myMessage. So we say sprintf, myMessage, then the format control string with the %s in, and then the file name gets substituted for %s. Next, we see sprintf used to produce the same result, but instead of supplying a variable for the first argument, we supply nil, and then assign the result of sprintf to myMessage. The effect here is the same, and it just shows you two different ways of using sprintf. The result again is the same, is that we create a string called myMessage with the value for file name substituted into the string.
In this section, situation, we'll be looking at how to solve common problems you may encounter when entering skill expressions in the command interpreter window.
When you're working with skill, occasionally you're going to run into some problems as you're entering commands. And what we want to do at this point is talk about some ways to identify those errors and fix them. So the first situation here is where, let's say you're entering data and at some point it appears that the CIW is not responding. Okay. The second case would be is you've entered a command, hit return, and you get an error message back. And you need to interpret that and move on. And the third one would be is where you're calling a function and you pass arguments incorrectly to that function and get some type of an error message. So let's examine the first situation here where what happens if the CIW doesn't respond. So the situation is you've typed in a skill function or command, you've pressed return, and your expectation is that it will execute the command and return a value, but instead nothing happens. So most likely you have one of these two problems. Somehow you've got unbalanced parentheses, meaning when you've hit return, skill doesn't think you're done entering the command because it doesn't see the correct closing parenthesis for the function or functions you're entering. Or possibly you've entered a string quote and then not close that string quote. So as far as skill is concerned, you've got a string that has not been closed and therefore is not ready to be evaluated. Now, the solution to either of these, and it kind of depends on the situation, but is to follow a couple of steps here. So let's assume you might have entered more left parentheses than right, meaning you need to close out at least one right parenthesis. In that case, you can enter a square bracket, which will close off all outstanding right parentheses. That should get it to execute. Now, whether all those right parentheses were supposed to be at the end of your command is another thing. In other words, if you forgot a closing parenthesis up farther in your code, it will now be closed off at the end. So even though it will execute, it doesn't necessarily mean it will execute exactly what you were intending. Now, if still nothing happens, then you could enter the single or the double quote followed by a square bracket, meaning the assumption is I need to close off a string and then close off the rest of the parentheses. And again, that can work, and again, you may not get the result you intended if that quote should have been farther up in your code rather than at the end. Now, another thing that works well is to just use Control-C. And Control-C will cancel the current command and reset the evaluator. So try the Control-C if you're in a state where you're not quite sure what the evaluator is doing, it's not responding, you're not really sure where you want the brackets to be, the parentheses, the quotes, and you just sort of want to start the command over. A lot of times Control-C will get you back to a state where the skill evaluator is ready to start a new command. Here we want to provide a little bit of a warning about white space. In skill, white space in the wrong place can cause error messages. So one guideline here is do not put any white space between the function name and the left parentheses. The error message is do not identify the white space as the cause of the problem. You'll get something related to that you'll have to interpret, which we'll look at shortly. And it can vary depending on the surrounding context of the code as to what error message you actually get. So here we have some examples. The first is a skill function to concatenate several strings. It's called strcat. And then we want to pass in several strings to the strcat function. Now everything looks fine except we have put a white space after the strcat command and before the left parenthesis. So when we do this, we get an error message and it says error eval illegal function A, which seems strange. It doesn't say you have extra white space, but essentially it's interpreting the parameter list as like a Lisp expression. If you recall, in a Lisp expression, the first item in the list is considered to be the function. So it's expecting A to be a function, which it is not, and it is complaining about that. So the key here is do not put white space between the strcat and the first left parenthesis. Now, here's basically the same error, but it's in a little different context. We're assigning the result of strcat to a variable. So we're saying greeting equals strcat work smarter. And we've left the white space in there as an error. And rather than giving us the error that we saw in the previous example, it's saying unbound variable strcat. And that's because it's evaluating left to right. So the first thing it sees is it looks like a variable called strcat needs to be evaluated and assigned to greeting. And then it'll worry about later this work smarter string we have. So again, in this context, same basic error, but a slightly different error message. And in both cases, the error is to remove the white space. Another potential error we need to be concerned about is passing incorrect arguments to a skill function. So all built-in skill functions will validate the type of the arguments you pass to it. You have to pass both the appropriate number and in the correct sequence. And each argument must have the correct data type. Now, if there's a mismatch between what the caller of the built-in function provides, so you and your program calling the particular function, and what the function expects, then you will get an error message from the skill evaluator. So here's an example where we're using the strcat function, and we're passing in this case, a string and a piece of numeric data. So strcat is designed to take strings and not numeric data. So here we have an incorrect type of data, and the message is actually fairly clear. It says argument number 2 should be either a string or a symbol. The type template is a capital S for string or symbol, and then it shows us the offending argument, which in this case is the number 5. So the type template mentioned in the error message encodes the expected argument type. Next, we see another example here called strlen. And the function of strlen is to take in a string and tell you the length of that particular string. Well, it requires at least one argument. So here when we call strlen parent and passing no arguments, we get the error message strlen too few arguments, 1 expected, 0 given. In this case, it uses nil as an indicator that we did not pass any arguments to the strlen function. So here it's checking the number of arguments we passed and identifying the error as not having the correct number. So when you're trying to determine what type of data to pass to a skill function, you can use the Cadence Skill API Finder to verify that you have, first of all, the correct number of arguments that the function expects, and then that you are passing in the expected data type for each of those arguments. At the right is a table that summarizes some of the different types of data that are expected for different types of input arguments.
So in summary, in this module, you learned how to enter skill commands using the skill language syntax. We looked at how to send skill expressions to the skill evaluator from a variety of inputs. We also looked at skill data, function calls, variables, and operators. Then we looked at how to display data in the CIW using a variety of print commands. And then finally, we looked how to solve some common problems you may encounter when entering skill commands.